That's interesting. By actually defining the trig functions. And maybe we'll start with this by just saying, well, we're going to work in radians most of the time in this class. Let's just remind ourselves what radians means. So suppose I have this circle here. Circle of radius 1. Suppose you rotate this way far enough that, I don't know, 2. Now you've walked a distance of 2 along the boundary. What's the measure of, how big is that angle in radians? Yeah. But there's this idea that the radian measure of an angle is the arc length divided by the radius. So that's the way we'll measure angles most of the time. It's a natural way to measure angles. There's not some random choice. You just measure some distances. That tells you the radian measure. So we'll walk in that language most of the time. And now I'll define for you the trig functions. So suppose you start at 1, 0 on the unit circle. Now I can draw the picture right here. You start at 1, 0 on the unit circle, so that's a circle of radius 1 centered at 0. You rotate forward by some angle, theta, usually measured in radians. There are the occasion that we'll walk in degrees. You now land at some point x, y. The trig functions are defined in terms of that point. The cosine of the angle theta is the x-coordinate that you land on. The sine of the angle theta is the y-coordinate you land on. Secant of this angle theta is 1 over x. So maybe if you want to say it a different way, that's the same as 1 over cosine of theta. Of course, something bad can happen. What can you never see in the denominator? 0. So, when 0 happens to be in the denominator, this thing is not defined. Cosecant of theta is 1 over the y-coordinate, also known as 1 over sine theta. Unless, of course, you divide by 0, then you just say it's undefined. Tangent of theta is the y-coordinate divided by the x-coordinate. And I'll draw a picture off to the side to point out what that means geometrically. Of course, that would be bad if x is 0. Now it's more legible than it used to be? Okay. And finally, cotangent is the x-coordinate divided by the y-coordinate, unless the y-coordinate is 0. So let's think about what cotangent means. Each of these have some geometric meaning, but I think cotangent is the one that's easiest to state. So let's see, you rotate forward by some angle theta. You land at some point xy. So let's see, there's the point 0, 0. There's the point xy. What's the slope of that straight line that I just drew? Let's see, what's the change in their y-coordinates? Y, right? What's the change in their x-coordinates? X. So what's the slope of that line? Y over x? Right, changing y over changing x. That's what tangent measures. Tangent is the slope of that line. If you rotate forward by some amount, the slope of that line is tangent. Makes sense? Those are the functions that we will be studying for basically the remainder of the class. We'll be extracting information out of them. We'll be evaluating them at specific inputs. We'll be using them to solve various geometric problems. But for now, let's just start by evaluating. So we have some specific instructions that give us the definition. So if you start at 1, 0, you rotate counterclockwise by some angle, that point is the coordinates of that point are the trig functions. So let's try to figure out the trig functions at an angle of pi over 2, also known as a right angle. So if you start at 1, 0, you rotate forward by pi over 2, then you'll be at this point. And what is that point? Yeah. So what is that xy coordinate now?
0, 1.
Yeah. So if you rotate forward by a right angle, 1, 0 becomes 0, 1. So x equals 0, y equals 1. Tell me then, what's the cosine of pi over 2?
0.
0, because it's the x coordinate. Maybe I'll even do the color coding shtick that I like to do sometimes. So cosine is 0. What's sine of pi over 2? 1. What's the tangent of pi over 2? Undefined, right? You would want it to be 1 over 0, but you can't have 1 over 0. It's undefined. What's the secant of pi over 2?
1.
Undefined.
I hear an undefined and I hear a 1. So let's go through it. So secant is 1 over the x coordinate. So that'll be 1 over 0. Ah, that's bad. Yes, that's undefined. What about cosecant? What's the cosecant of pi over 2?
That's 1.
That one's 1, because it'll be 1 over the y coordinate. So that'll be 1 over 1. Yeah, that's just 1. What about cotangent? I hear a 0. Is that the consensus? Oh, right. Nice. So as long as you can understand these sorting pictures, you can figure out trig functions at least at particular angles. Next, let's think about an angle of pi radians. That's halfway around the circle, 180 degrees if you insist on thinking in degrees. So start at 1, 0. You rotate by half of a full revolution. What point do you land on? Negative 1, 0, right? You've gone half of the way around the circle. So that point at 1, 0, rotated half the way around the circle, will become negative 1, 0. All right. So now I'm going to be quiet for like 2 minutes, and you will tell me what the trig functions are at pi. All right, the cosine of pi is negative 1. Sine of pi?
0.
0. Tangent?
0.
0. Secant? Cosecant? Cotangent? People feel pretty good about that? Nice. So the thing that we will do next time is we will establish the following fact. So if you stand on the unit of 0.10 on the unit circle and rotate by pi over 4 radians, so that's half of a right angle, It's maybe really easy to believe that if you do that, you should land at like a point where the x value is equal to the y value. All right, that's all the way down. Our right angle is all the way up. Halfway between should be like the x going up is the same as the y going up. So, if you believe that, then it's easy to get this, but I don't want to focus on that anymore on this. You land at the point √2/2 comma √2/2. Is that enough information to compute all these trig functions? So maybe I'll take the mindset of I'll go across the top row, and then I'll leave the bottom row to you. And you'll notice something similar happens between the top and the bottom row. So tell me, what's the cosine of pi over 4? What's the tangent of pi over 4? I guess it'll be the x coordinate, √2/2, divided by the y coordinate, √2/2. What does that simplify to? 1. Right, you could say, well, I see a fraction in the denominator, so I'll multiply by the reciprocal. But don't do that, don't do that. You just see the same thing in the numerator and denominator. A thing divided by itself is always 1. Secant of pi over 4. So I guess this one you actually have to do some stuff. So that'll be 1 over the x coordinate, 1 over √2/2. And let's start manipulating that. So that's 1 over a fraction. That's the same as the reciprocal of the fraction. So that's 2 over √2. On the one hand, there is an answer. But there's something that makes me unhappy about that answer. I have a square root in the denominator. So what do you need to do to this fraction to get rid of that square root in the denominator? Square root would get rid of the thing in the denominator, but that would change the number. So I need to like multiply and divide by a single same thing to get rid of the square root. So what would you want to multiply square root of 2 by to get rid of the square root? How about the square root of 2? Yeah. So I'll multiply and divide by √2. And hopefully this will all simplify nicely. So what does the numerator, so the numerator I'll just multiply it. It's now 2 square root of 2. What is the denominator now equal to? Just 2? Right, square root of 2 times the square root of 2 is the square root of 2 squared. And what's the whole point of square root is undoes squaring? Nice, so there's not a square root in the denominator anymore. Does it simplify? What's it simplify to? √2. Nice. Alright, so now I think I'm going to be quiet for like a minute or something. Tell me what the sine, cotangent, and cosecant of pi over 4 are. Seems useful to have that on the board. Certainly by the end of the semester, I expect all of these things to be things that you have bonded into your brain, but given that it's only been 20 minutes, maybe we can have it written down for a little bit yet. Right, so let's do it. Sine of pi over 4 is is the same thing as above. Cotangent of pi over 4. And it's in fact the same thing for like the same reason, right? Nice. Cosecant pi over 4. Cool. People feel pretty good about that? Nice. So something that's useful to have for any function is just like some lookup tables. And we'll build them to some extent. You have calculators, but let's write down this lookup table. So we've computed trig functions at some angles. We've computed trig functions at pi over 2. Cosine was 0. Sine was 1. Tangent was undefined. Secant was undefined. Cosecant was 1. Cotangent was 1. We walked at pi. Do you think we could probably figure out those remaining entries? So I think here's the way I'll go for it. I'll talk to 0. You will go through an angle of 3 pi over 2. You will go through an angle of 2 pi, and then we'll come together. So let's talk through what happens when we rotate by an angle of 0. So I'll draw a picture for this. So all right, we start at the point 1, 0. And I rotate by an angle of nothing. So I start at 1, 0, and I do nothing. If I start at 1, 0, and I do nothing, what is the x-coordinate that I land on?
1.
1. Same one as I was already at. What's the y-coordinate?
I was going to say for pi over 2 for the cotangent, it should be 0 since I watched it.
Yep. Thank you. Yeah. So, if you start at 1, 0, you rotate by 0, you land at 1, 0. So what's the x-coordinate that you land on?
X1.
1. And the y-coordinate is 0. So cosine of 0 is 1. Sine of 0 is 0. And maybe we'll think about tangent in terms of slopes this time. What's the slope of this horizontal line? Yeah. So tangent is 0. What's the secant? 1. All right, it should be 1 over 1, which is 1. Cosecant? All right, you have to divide by y, but y is 0. Cotangent? Nice. So here's what I want you to do now. Go through the same motions, draw a picture, figure out what the rotations at these angles will do. To tell me what the trig functions at 3 pi over 2 are, and tell me what the trig functions at 2 pi are. Alternatively, if you get to the point where you feel stuck, it's noise. No. All right. So people feel ready to talk about 3 pi over 2? All right, so you rotate by an angle of 3 pi over 2. Where do you land? And I did see at least one possibly just like point down, which I guess conveys the relevant information. All right, so it's 3 pi over 2, there's a pi over 2, pi over 2, pi over 2. So yeah, there's 3 pi over 2. All right, so what's cosine of 3 pi over 2? Sine? Tangent? Secant? Because you can't divide by 0. Cosecant? Cotangent. Groovy. Does that feel pretty okay? All right. Now for 2 pi. So if you start at 1, 0, and you rotate by an angle of 2 pi, what point do you land on? 1, 0, right? 2 pi is all the way around the circle. So if you start at 1, 0, you walk all the way around the circle to end at 1, 0. You're at the point where you started. So what's the cosine of 2 pi? Sine?
0.
Tangent?
0.
Secant?
1.
Cosecant? Cotangent. Groovy. People feel pretty good about that? Nice. So, for other angles, other than these cardinal directions, maybe it's harder to figure out exactly where you land when you rotate by just thinking about it and doing some geometry. But there's one thing that you can figure out easily enough, and that's should sine, cosine, tangent, cotangent, whatever, be positive or should they be negative? You can figure that out by thinking about what quadrant you land in. So let's try to think about trig functions at 2 pi over 3, which is something we will be able to compute on the nose tomorrow, maybe the next day. So let's try to just figure out what quadrant that angle is. So here's how I'll think. I'll draw myself my circle. I guess it can even be on the paper so that you draw it too. So there's an angle of 0. You start at the straight line from the origin to the point 1, 0, and you do nothing. There's an angle of 0. A right angle, there's an angle of pi over 2. By just thinking about how big pi over 2 versus 2 pi over 3 is 2 pi over 3 between 0 and pi over 2? No, 2 pi over 3 is like bigger than pi over 2. Like 2/3 is a half and then another 6th. Is 2 pi over 3 somewhere between pi over 2 and pi? Well, ignore the pi for a second. Is 2/3 somewhere between 1/2 and 1? It is, isn't it? All right, 2/3 is less than 1, because 1 is 3/3. But 2/3 is bigger than a half. So yeah, it's between. So 2 pi over 3 sits somewhere in that quadrant. Oh, maybe let's just remember what the name of that quadrant is. What's the name of that quadrant? Quadrant 1, quadrant 2, quadrant 3, quadrant 4? Quadrant 2. So in quadrant 2, while I'm looking at that picture, is the x-coordinate positive or negative? Negative. So that means that the cosine of 2 pi over 3, that's the x-coordinate, is negative. What about the sine of 2 pi over 3? Positive or negative? What about tangent? Let's write down the intervening steps. Let's see, tangent of 2 pi over 3. That'll be the y-coordinate divided by the x-coordinate. Is y positive or negative? So it'll be positive divided by, is x positive or negative? Is a positive number divided by a negative number positive or negative? That seem pretty okay? Tell me about cotangent. Positive or negative? Positive? Nice. There are some hands that didn't go up, so maybe I'll talk through it. I think it is negative. All right, so cotangent. What is cotangent in terms of x and y? It's x divided by y. X is, y is, a negative divided by a positive is negative. Cool. How about secant? Positive or negative? Here are negative. Let's see. Is there any controversy? Anyone want to say positive? Negative? Cool. Yeah, it's going to be 1 over a negative number. It's negative. What about cosecant? Positive. Groovy. So you could do this for basically any angle. If you can figure out what cardinal direction, so what multiples of pi over 2 an angle lives between, you can figure out all of the trig functions of that angle, at least in terms of whether they're positive or negative. And that will be useful for something that will occur on the very next page. But let's maybe fill in a little table. So let's see. There's an angle of rotation of 0. There's an angle of rotation of pi over 2. Those angles between, what quadrant do they trace out? Oh, yeah, sorry. Thank you. So an angle of 0, an angle of pi over 2, angles between. What quadrant does that trace out? 1? So if an angle lives in quadrant 1, what can you tell me about its cosine? Positive or negative? Positive, because it'll be x. Sine? Positive, because the y value is positive in quadrant 1. Tangent? Positive, because it'll be positive divided by positive. Secant? So secant should be 1 over x. X is positive. 1 over a positive is positive. I think they're all positive for that reason. Between an angle of pi over 2 and pi, what quadrant does that give you? Quadrant 2. So cosine is positive or negative? Sine? Tangent?
Negative.
Secant? Cosecant? Cotangent? Nice. So I think with the rest of them, I'll say the quadrant and then we'll just figure out sine and cosine. The remaining entries you can figure out on your own, probably in less time than it'll take me to say this sentence. So let's do that. Between an angle of pi and 3 pi over 2, what quadrant do you see? 3? Because you'll see these angles. So cosine is positive or negative? Sine? Negative, right? Because you'll see a point like this in quadrant 3. The x coordinate is negative, so sine is negative. Y coordinate is negative, so x is negative, so cosine is negative. Y is negative, so sine is negative. And maybe I'll say tangent too. So tangent will be a negative divided by a negative, which is between 3 pi over 2 and 2 pi, you see what quadrant? Quadrant 4. So the x values will be positive. The y values, so sine, will be, and maybe tangent. Tangent is then negative, because it'll be a negative divided by a positive. Between an angle of 2 pi and 5 pi over 2, what quadrant do you see then? Well, just by noticing the pattern, it should be quadrant 5, right? Is there a quadrant 5? Let's just draw them. So there's an angle of 2 pi. You go all the way around the circle. Then there's an angle of 5 pi over 2. That gets you back to vertical. What quadrant sits between those two? Quadrant 1. So cosine is Sine is, tangent is, everything's positive. That feel pretty okay? Cool. So, on this last page, here's something that you can do with this. So maybe I'll ask this. How many people carry their calculators with them every day they come to this class? So this exercise will have you determine whether your calculator is thinking in degrees or thinking in radians. And we'll do that by answering this question without using a calculator. Let's determine whether these quantities are positive or negative by thinking about what quadrant they're in. So let's try to figure out whether the cosine of 4 should be positive or negative by thinking about what multiples of pi over 2 it lives between. So let's see, pi is somewhere around 3.1. So pi over 2 is somewhere around 1.5-ish. I'm not trying to be super precise. So is 4 between 0 and pi over 2? No, 4 is too big. Pi itself is somewhere around 3.1. Is 4 between pi over 2 and pi? 3 pi over 2 is somewhere around 4.6-ish. Is 4 somewhere between pi and 3 pi over 2? Cool. So 4 is between those two angles. So what quadrant does an angle of 4 put you in? Quadrant 3? So cosine of 4, positive or negative? Nice. That idea make sense? Do people feel comfortable with the idea of doing the same thing for an angle of 0.2 and an angle of 7? People want me to talk through those examples as well? Okay, so you can go to bed. I'll just be quiet for a moment. Tell me, are those quantities positive or negative? Cool. Tangent of 0.2 is positive. That sounds right. Cosecant of 7 is? You sound not very confident. So let's maybe see a show of hands. Positive? Anyone want to say negative? Yeah, positive. Right, 7 is a little bit bigger than pi, but not so big as 5 pi over 2.
So we said 5 pi over 2 would be the angle then at the maximum?
Yeah. Right, since there would be 2 pi, also known as 4 pi over 2. So an extra pi over 2 would put you back up here. Nice. Cool. So let's now take a moment. I'm going to have you take out your calculators. Ask your calculator for cosine of 4, tangent of 0.2, cosecant of 7. Maybe we'll start with cosine. I think I'll do it now. So compute cosine of 4. What do you get?
0.65 radians.
So again?
Or cosine of 4, I got 0.65.
0.65. Okay, cool. That sounds right? Good. Wait, 0.65? So, positive. All right, excellent. That's exactly the, wait, so it was negative?
Yeah.
Did anyone get a positive number? Nice, what positive number did you get?
0.997.
0.997. Nice. So here's what we are noticing. For those of you who are getting this negative number, your calculator is walking in radians. What your calculator just gave you was the cosine of 4 degrees, which makes sense that it would be that. And if you start at 1, 0, 4 degrees is like really small. So start at 1, 0, rotate by just a little bit. The x-coordinate is basically still 1, with your plus. So there's a way of checking if you have a machine, whether your machine is incorporating results in degrees or radians. There is a way to translate your machine to radian mode, and for everyone else to degree mode. You'll need both at different times. You should consult your manual or something and figure out how. Otherwise, you'll have to remember how to convert from radians to degrees, which isn't that bad. Just multiply by pi over 180. Cool. Do people feel pretty good about that exercise? All right, so there's one last thing that I want to do. And that is developing what maybe you would want to call the most important fact about trigonometric functions, the Pythagorean identity. And here it is. It'll show up right there. It'll tell you the cosine of any angle squared plus the sine of that same angle squared is always a particular number. Let's figure out what that number is. So, let's do it by thinking about geometry. So, start at 1, 0 on the unit circle. You rotate forward by some angle theta. You land at a point xy. Now, this is a circle of radius 1, right? So since this is a circle of radius 1, what can you tell me about the length of this line segment? It's got to be 1. But we can also compute the length of that line segment by the distance formula. So that will tell you that the difference between the x-coordinates is x squared, the difference between the y-coordinate squared is y squared. X squared plus y squared is 1. Because this is a point on the unit circle. But now let's translate back a little bit. In terms of trig functions, what is x equal to? Cosine? What's sine equal to? No, wait, what's y equal to? So that tells us something. That tells me that the square root of cosine squared theta plus sine squared theta is always equal to 1. And I wasn't intending to introduce this notation yet, but, right, so you end up squaring trig functions often enough, and this gets awkward to write. So whenever I want to take a trig function and square it, I'll like sometimes put the 2 right there. It's a slightly awkward convention, but it's also the standard convention. All right, so there's a fact, and let's just simplify it a little bit. What's 1 squared? 1. So if I square both sides of this, do I get something simpler looking? Yeah. Here's the Pythagorean identity. Pythagorean identity tells you that for absolutely every angle theta, cosine squared of theta plus sine squared of theta is always equal to 1. And if there's one thing that you should remember throughout the remainder of this class, it's that fact. And you can get some things out of this fact. So this is an equation that tells you something about the relationship between sine theta and cosine theta. Do you suppose if you knew what cosine of theta is, you could probably solve that to figure out what sine of theta is? Yeah, absolutely. Let's do exactly that. A thing we will get soon is that the cosine of pi over 3 is 1/2. Let's use that to try to compute the sine of pi over 3. And yeah, there are some typos. Most of those cosines should be sine. So let's try to do that. So I'm going to do the walk over here. So I know that cosine squared pi over 3 plus sine squared pi over 3. What should that be equal to according to the Pythagorean identity? 1. No matter what thing you have in there, that sum of squares is always 1. All right, what's the cosine of pi over 3? 1/2. And that's something that's just written down now. We don't know why it's true, but it's 1/2. So this will give me 1/2 squared plus, and there's something that I'll do a fair amount when I'm doing computations like this. I don't want to write sine all the time. So I'm just going to replace the sign with an S. That look like you could solve that for S? I think so. Right, because what's 1/2 squared? 1/4. So I can subtract a fourth from both sides to get S squared equal to 3 over 4. All right, what would you want to do to figure out what S is? Take a square root, and I'm going to do something wrong, and you'll tell me what thing I've done wrong. So S is equal to the square root of 3 over 4. What's wrong? Plus or minus. And then I'll also say, well, if you see a perfect square under a square root, you can pull it out. If you see any perfect squares in 3 divided by 4, 4 is a perfect square. So that means that the sine of pi over 3 is plus or minus the square root of 3 over 2. And now we're going to bring everything together now. What quadrant does an angle of pi over 3 live in? Is pi over 3 less than pi over 2? Yes. Right. Dividing by 3 makes you smaller than dividing by 2 makes you? So pi over 3 is like there-ish. What quadrant is that? 1. So is sign positive or negative? Positive. So does it actually matter that there was the plus or minus? Could I have just taken the plus? In fact, I have to take the plus. Cool. So I now have cosine. I have sine. I have 4 minutes left. I think that's enough time to compute some more trig functions. So I'll start with secant. So let's see. Secant is 1 over the x-coordinate. So that's 1 over cosine. So secant theta is 1 over cosine pi over 3 is 1 over 1 over 2. What's 1 over 1 over 2? 2. Right, you multiply by the reciprocal. If you wanted to compute cosecant, that is 1 over y, so 1 over sine. And I guess, in some sense, there is an answer, but we should probably simplify that. I see a fraction in the denominator, so that's really the reciprocal. That's equal to 2 over root 3. I see a square root in the denominator, which makes me slightly unhappy. What should I multiply and divide by to get rid of that square root? Root 3. So I'll multiply by root 3. I'll multiply by root 3 in the denominator to make sure I don't accidentally change the fraction. Giving me 2 root 3 over 3. Cool. And so we've got enough time to do cotangent and tangent as well. Let's compute cotangent. So cotangent is the x divided by the y. So it'll be 1 over 2 divided by root 3 over 2. All right, so now it's like a little bit more complicated. But both the numerator and denominator are divided by 2. So I can cancel the divide by 2's, right? So it's 1 over root 3. What should I multiply and divide by to get rid of the root 3 in the denominator? And maybe you can even do that without writing anything. And let's do tangent. I think we have the time. So tangent is x over y or y over x? Y over x. So that'll be sine divided by cosine. So tangent is sine is root 3 over 2 divided by 1 over 2. And what's that simplify to? Just root 3. So here's the takeaway of the thing that the Pythagorean formula, Pythagorean identity gives you. If you know a trig function and like something to tell you about a formula, then you know all the things.